Hi guys, this is Bipin Kumar. Welcome to the world of spatial information technology. This is the second video in this channel under the head of automating GIS process. Here we'll discuss the first and fundamental package of data analysis, that is NumPy. It's a fundamental package for scientific computing with Python. Before going forward, I request please watch the introduction video of automating GIS process. I have given the link into the description. Also, I will recommend set up the Python environment by installing Miniconda and use Jupyter Notebook to do the practice of Python code. Or else you can also use Python console. Here is the installation guide of Miniconda and other Python module for data analytics and visualization. I have given the installation guide link into the description. To install any Python module, type the following command after installation of Miniconda. Conda install package name. If it will not work, then you need to type pip install package name. Here example is also enlisted below. Like if you want to install the NumPy package, simply you need to type conda install NumPy, and same is implemented for other Python module. Here I have already installed Jupyter Notebook and data analytics and visualization package, that is NumPy, matplotlib and pandas. So to move forward, I am opening Jupyter Notebook terminal. To save your time and keep this video brief, I have already typed the code for all the functions of NumPy that I am going to explain in this video. In the first kernel, I am importing NumPy as NP. In the second kernel, I am creating one-dimensional array using the function arange. It will create one-dimensional array from indices 0 to specified value. You can see in the output, it is created one-dimensional array value starting from 0 to 9. You can also perform any numeric operation on this number. If you want to calculate square of any array, then simply type the following command: np dot square and the array name. You can see the output. It is calculating the square value of individual element. And same, you can also calculate square root of any array. You need to type np dot square root and then array name. You can check the output. It creates the square root of individual array. Move to the next kernel. In this kernel, you can check statics value of array by calling the NumPy function max, mean, standard deviation and variance. Here you can see the output. First one is maximum value of this array, that is 9. Second one is minimum value of this array, that is 0. Third one is average value of this array, and fourth one is standard deviation of this array, and fifth one is variance value of this array. Move to the next kernel. Here I will discuss slicing of an array. This is very important operation while you are playing with an array. First, see the output. The first output will give the value from 0 indices up to 5. The second output will give the value from 5 indices onward. You can see here the fifth indices will started from the value 5 and it will go up to last value. You can see the output 5, 6, 7, 8 and 9. Third output will give the value from indices 4 to 7. You can see here fourth indices value will start from 4 and it goes up to 6. You see the output 4, 5 and 6. The next output will give every second value of an array starting with indices 0. You can see in the output the first value is started from 0, 2, 4, 6 and 8. Next output will give again every second value of an array starting with indices 1. You can see in the output the value is started from 1, 3, 5, 7 and 9. Final output is interesting. This is basically the smart use of upper slicing. It will reverse the array. You can see in the output it is reversing this array. The value is started from 9, 8, 7, 6, 5 and up to 0. Move to the next kernel. This kernel will gives an idea about the property of an array, like what's the shape, size, data type, dimension. First you can see the output here. Here shape gives rows and column value of an array. Size gives the total number of element in the array, and d type basically gives an information about the data type of an array, and ndim basically gives the idea of dimension of an array. Here you can see in the output total number of column value is 10, that's why shape value gives 10, and total number of element is 10 here, that's why arrow dot size gives the value of 10, and since all these value are integer, so data type is integer 64 bit, and since this is one dimensional array, so this value gives 1D. You can also change the data type of an array by using the function of else type. You can see the data type of the demo array, demo dot d type. You can see the data type of this demo array is float 64 bit. Now move to the next kernel. Here I will discuss list is not an array. Here I have created one demo list. You can see the output here. If you want to perform any numeric operation on this array, you cannot perform. You can see here demo list. Suppose if I want to add the number 10 here, it will give an error because this is not an array. For this you need to convert above demo list into an array. It will become multi-dimensional array. You can see the output of multi-dimensional array. Here you can easily perform the numeric operation on multi-dimensional array. Simply you can type multi-dimensional array. If I want to add 10 on every individual element, you can get the output like 1 plus 10 11, this is 10 plus 2 12, 13 and so on. You can also convert multi-dimensional array into one dimensional array. Simply you can type multi-dimensional array dot flatten. You can see the output here. this multi-dimensional array is converted into one-dimensional array. You can also check how many unique element in this array. Simply type np dot unique and the array name multi-dimensional array. You can see here 1, 2, 3, 4, 6, 8 and 9 is unique element in this array. Look at duplicate is 2, 2 is removed. Duplicate value of this array is removed here. You can also calculate the statics of multi-dimensional array. Simply type multi-dimensional array dot, if you want to get the maximum value, you can see 9 is the maximum value of this array. If you want to calculate the minimum value, simply type mean. See here, 1 is the minimum value of this array. If you want to get the average value of this array, simply type multi-dimensional array and mean. This is the minimum value of this array. Same, you can type std for calculating the standard deviation of this array, and var for variance of this array. Now move to the next kernel. Sorry, now again I will discuss slicing of multi-dimensional array. First, see the output here. The first output will give the value at 0th indices, that is 1, 2, 3. If you want to check the output at the second indices, you can simply write multi-dimensional array. If I want to check the value at first indices, you can see here this is 4 to 6, here it will come 4 to 6 here. And if you will give here -1, it will give the value of an last element of the array. You can see here 3, 8, 9 is the last element. You can see the value 3, 8, 9. This will give the value of the column at second indices. That is, this is first indices, this column is at first indices, this is second indices, this is at 0 indices, this is first indices, this is second indices. You can see the output here 3, 6, 9. So this output will give the value of column at second indices, and the final code will give the output of every second row. Like this is the first row, just leave this one, this is second row. So final output will give 1, 2, 3 and 3, 8, 9. You can see here. Now move to the next kernel. Here it is describe the properties of the multi-dimensional array, like shape, size, data type and dimension. First, see the output here. Since this multi-dimensional array is 3 by 3 array, so the shape of this array is 3 cross 3. It means total number of rows is 3 and total number of columns is 3. And since total number of element in this array is 9, so size of this array is 9, and data type of this array is integer. Look at here, this all data type shows the integer value. So data type is integer 64-bit, and since it is two-dimensional array, so NDIM is showing 2, it means two-dimensional array. Now move to the next kernel. If you want to generate one-dimensional array of zeros having 5 element, so simply you need to type np.zeros 5. You can see the output. One dimensional array of zeros with having 5 elements is generated. Same, this kernel will generate the array of zeros with size 5 by 2. You can see here an array of 5 rows and 2 columns is generated here. Same, you can create ones array by using the function of ones of NumPy. You can see the output here. An array of ones having rows 2 and column 5 is generated here. Now move to the next kernel. This kernel output will give an random array with size 2 by 2. You can see here one random array of size 2 by 2 is created here. Now move to the next cell. This kernel will also give some random array with a specific mean 0 and variance 1. You can see the output here. Now move to the next and last kernel. This kernel will create an random array having integer value in the range of 10 with a specific size. Here x1 is a one dimensional array of random integer having size 6. x2 is a two dimensional array of random integer having size 3 by 4. x3 is a multi-dimensional array of size 3 by 4 by 5. You can see the output here. x1 is one dimensional array, x2 is two dimensional array of rows 3 and column 4, and x3 is multi-dimensional array. That's all for this video. Hope you enjoyed the learning. If you really like this video, don't forget to hit like, share and subscribe this channel, and also press the bell icon so that coming video will notify you first. Sign off for today. Bye bye.